This is one of those sections I honestly have been dreading to teach this way because it is so much better to teach this live with a classroom full of students because this is tricky. Maybe one of the trickiest things we've done. Depends on how spatial you are with your thinking, okay? So today we're going to be doing 6.2 similar right triangles formed from altitudes. And the best way I thought to proceed through this lesson is to use the simulations that Delta Math has. So you'll see that happening in some of these videos. And you definitely will want to take advantage of that in your homework. Now, the first thing I want you to have the note card 184, which is what an altitude of a right triangle is, and the right triangle relationship. So the altitude to the hypotenuse of a right triangle, oh goodness, the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original and each other. That is a lot to say. So I really don't want you to do your note cards yet. I want you to listen to what I'm saying because this is so much to take in. I don't want you to try to draw them yet. I don't want that to happen. So wait to do your note cards. Okay, I know it's going to take a little longer. I know. Okay, so this right here, this BD is the altitude. And so I wanted you to see me type this. The altitude, did I spell that right? Yeah. The altitude, here is the right triangle, the original big right triangle. And the altitude comes from the right angle and goes straight down and forms a right angle with the other side. Okay, so weird, BD is what we call an altitude. It comes from a vertex, it goes to the other side and makes a right angle. Okay, now what happens is you had a big triangle that was a right triangle. Okay, and then you drop an altitude from that right angle. Okay, and it creates two other little triangles here and here. And if you split all three triangles, they are all similar. They are all similar, and you really need to visualize how this would work. So this right here is similar to the big triangle, and this right here is as well. And you have to look at the leg lengths, and the hypotenuses would match up. Tricky. So the altitude to the hypotenuse, so this is the hypotenuse of the big right triangle that's sitting here. Funky, we're used to seeing them kind of sitting up. That altitude to the hypotenuse of this right triangle divides the triangle into two triangles that are similar to the original and to each other. So this ABC is similar to ADB. Let's think about it. AB is the smaller leg of the big triangle. And if I look at this one, AD is the smaller leg of this triangle. So AB is going to match up with AD. Okay. And then look at this one. Look at this right triangle. Which one's the smaller leg, BD or CD? It's BD. So BD is going to match up there. You might have to rewind me and listen to that again because that's a lot to think about. Now, the next examples, you're going to hopefully start seeing how this works and see the relationship. You can Google things about this and find some gimmicks and some tricks, and that's fine, but I'm not teaching those yet. I want you to truly understand what's going on. So what I've done, if you look up here on the side, is we have a series of 3 examples that are taking up 9 note cards for a total of 10 note cards, okay? So you'll see I've got it color-coded, like these 3 have a highlight on the top of purple. Over here on the left is where I'm looking. These have a highlight on top of green, and these have a highlight on top of like that bluish color. So those all go together. Okay, so let's look here at note card 185. So here's a scenario, okay? Given the right triangle ABC with altitude BD drawn to hypotenuse AC. So first thing I want you to do is draw the first picture. So here it is. We've got the big right triangle. Yes, you need the little box there. We label it ABC because it said the altitude BD is drawn to the hypotenuse, and that's how I'd know B would be right here, okay? And that's D. And it says AB is 8, AD is 4, and it wants the length of AC. That's what's going to be happening, and we're going to be answering that. But first, I just wanted you to get in the feel of drawing that first picture. So now, realize you would have to draw this picture on your own. It wouldn't be given to you. You'd have to draw this and label it. So we knew it was ABC and an altitude BD. So I knew that B had to be the right angle. Go ahead and pause me and finish up your first 2 note cards.